Hi everyone, this is Faith Mbella, and this is the final presentation of the results from my analysis on crimes in Minneapolis. This is for data 670 taught by Dr. John McKeeby. So overall, this project was based on data sets for crimes in Minneapolis and police top data sets. The two data sets were cleaned by removing outliers, missing values, unnecessary columns, adjusting data types as required. New columns were also created by splitting the reported date column into two, putting the date on one column and the time in another one. Another new column was created from the time column, which identifies what time in the day it was. Was it morning, afternoon, evening? The morning started from 5 a.m. to 11 p.m. 11 a.m. Afternoon started from 12 to 5 p.m. Evening started from 5 p.m. to 9, and night started from 10 to 5 a.m. After all this was done, the two data sets were combined and joined at the precinct. Because the precinct was found in both data sets, we used this column to combine both data sets. The column, yep. So for this, after the two data sets were combined, we had to build machine learning models that were used to determine which features best affect the predictors. Before I forget, a new column was created, which was called the hot zone. The hot zone is the target variable for this data. So the hot zone is made up of crimes. Is a categorical variable which is either 1 or 0. 1 was for crimes that occurred more than 1,000 times in a day, and 0 was for crimes that occurred less. So it is either low crimes or high crimes. So hot zone was or is the target variable for this analysis. So for this analysis, it was seen that time of the day, neighborhood, race, call, disposition, and reason are the main factors affecting crime rates in Minneapolis. The first machine learning model that was created is the decision tree. So from the decision tree, it can be seen that the neighborhood is the number one variable that affects high crime rates in Minneapolis, followed by time of the day. So from the decision tree, the results show that neighborhood was the main factors affecting crimes in Minneapolis, and neighborhoods like Bancroft, Bottineau, Bryn Mawr, Korak, Cedar, Isdin, Central, Como, Copper, Corcoran, Diamond Lake, Downtown East, Downtown West, East Harriet, East Owls, Echo, Erickson, Field, Fulton, Hill, Keewaydin, Kenny, and many others had the highest crime rates. And also in the afternoon and in the evening, crimes were slightly higher compared to other times of the day. So this reported a 94.7% chance that crimes will be committed in these regions, which ironically at night there is a slightly lower chance of crimes being committed, high but lower as compared to afternoon and evening. and can be seen by 90% as compared to a 94% in the afternoon and the evening. So nights were relatively safer in this neighborhood. There is also a 92% chance of a crime being committed in the morning or afternoon in neighborhoods like Armitage, Auburn, Park Bryant, Columbia Park, East Phillips, Hiawatha, Holland, Loring Park, Lindale, Marshall Terrace, McKinley, Midtown Phillips, Northrop, Phillips West, Prospect Park, East River Road, Sheridan, Ventura Village, Wyndham, and Wyndham Park. So in the morning, there is a 92.5% chance that a crime, a very high crime, is going to be committed in these regions. At night, there is a slightly lower chance of crimes being committed in Fowler, Howard near the north, and Prospect Park in East Riverwood. This percent is about 87.3%. Crimes in these regions are mostly called in by the citizens or the residents in these areas. The decision tree model had an accuracy of 92.18 in the training datasets and 91.91% in the testing datasets, which is pretty much high. So we go for the second model, which is the rainforest model. The rainforest model was created with 200 trees built and 3 variables tried and split at each split. So for the rainforest, the important variables can be seen with the value of the mean decrease Gini. Now the mean decrease Gini shows that the most important variable for this analysis is the call disposition. It had a mean decrease Gini of 300. The higher the Gini, the Gini value, the more important the variable is. The precincts and the race had a little over 200. The pre-race about 175. Gender a little over 100, persons search about 60, and vehicle search about 50. From these numbers, you can see that a call disposition, the type of call that was made, it determines if there was a crime or not. And this variable importance here shows us the mean decrease Gini of the variables in this data set, of the most important variables in this data set, which can be call disposition, precinct, race, pre-race, reason, time of the day, problem, gender, person search, and the vehicle search. So these were determined to be the most important variable from the data set according to the rainforest model. The model accuracy for the rainforest model was 92.6%, sensitivity 5.5%, and specificity on the other hand was 99%. This was because the dataset was highly skewed. The third model is the naive Bayes model. The naive Bayes model shows us the a priori probability for the crimes. So for high crimes, the a priori probability is 0.919, and that of low crime is 0.08, as seen on this figure right here. In R, the rows function was used to balance the skewed target variable because the variable is more highly skewed. The rows function is used to balance the variable. When the target variable was balanced, the apparent probability for high crimes is came down to 0.5, and for low crimes came down to 0.49. The conditional probabilities came for the naive Bayes model shows us that if a 911 call is made, the chance of it being a crime is 32.7%, and the chances of it not being a crime is at 29%. If the problem is a suspicious person walking around the neighborhood, the chance of this being a crime is 29.16%, and the chance of this not being a crime is 29.19%. If the problem is a suspicious vehicle, the chance of this being a crime is 20%, 20.75%, and not being a crime is 20.66%. For traffic stops, the probability that a crime occurred and a citation was issued is 15.15%. Also, if the vehicle is searched, the chance that there was a crime is 7.94%, and the probability that the vehicle was not searched and a crime did occur is 92.06%. The chance that a crime occurred and the culprit was black is 34%. The chance that the crime occurred and the culprit was a white person is 23.7%. If it was an African person, the chance of a crime being occurred is 4.59%. A Latina person is 3.85%, and a Native American person is 3.4%, and an Asian is 1.35. So we see that Asians in Minneapolis have the lowest chance of committing a crime. If a crime occurred, the chance that it was done by a female is 20%, and the chance that the crime was committed by a male is 62%. Also, the chance of crime occurring at night is 24.43%, and the chance of a crime occurring in the evening is 33%. In the afternoon is 25%, and in the morning is 16%. So looking at this, looks like the safest time in Minneapolis is in the morning, and then followed by the nights, and then the afternoons, but the evenings are usually rough. The accuracy for the naive Bayes model is 93%. Comparing all three models, we can see that the naive Bayes model had a 93%, the decision tree had 91.91%, random forest 91.87%. The average root square error for naive Bayes is 0.2687, random forest is 0.2689, decision tree is 0.2698. So from these figures, we can see that the naive Bayes model is the best model of all three, which is shown by a lower average root square error and a high accuracy. So misclassification in the naive Bayes was very low as compared to decision tree and random forest. So I used the SAS enterprise model to compare all three variables, and the naive Bayes model came out to be the best. The important variables for this analysis came up to be time of the day, called disposition, the race, and the gender. It showed that the black race committed more crime and the male also committed higher crime. And we also saw that the evenings are not usually safe in Minneapolis, and most crimes are being called in by citizens in Minneapolis. For this analysis, SAS Enterprise Miner was used to build some of the models. R programming was also used to build models. Python was used to clean and prepare the dataset. Microsoft Excel was also used to further prepare the dataset. And Tableau was used to visualize the dataset. This is the end of my presentation. Thank you.